Good morning, everyone. Hope the ASMS is going well and treating you well. We are on our second day of breakfast workshop, and as we say that we are also saving the best for the last. So we have a pretty amazing group of speakers, two in particular, Lynn from Children's Hospital of Pennsylvania and Mo from Broad Institute, with some outstanding talks that I am actually looking forward to it. So I'm actually right in between you guys and some really good discussions or presentations. So I'll try to push myself a little fast. My name is Deb. Don't need to remember. I also don't feel like remembering my full name nowadays. So, but anyways, let's get started. Why we are in the space of proteins, what we are doing over here. It's probably, I think I'm preaching to the choir if I have to say why we have to do proteins. You are all familiar with the need and the requirements. I was speaking to someone yesterday and I said, most of the drugs and therapeutics are targeting proteins. So knowing things at a genomic level and not knowing the proteomic distribution that need to be targeted probably is a gap that we are trying to now. I think for the last 10, 15 years, people have been trying to address the gap. Mass specs have helped, but I think there's a lot more to come, because where a 1.6 million resolution mass spec may not be able to do it is if the sample is not good. And that's exactly where we come in when it comes to our sample preparation capabilities. So for those of you who are not aware of what we do, we have an acoustic energy-oriented workflow where we deliver an acoustic energy. You can call it sonication, but unlike most of the other sonication devices or sonicators, where we are different is our ability to keep things, the pressure on the sample distributed, temperature controlled, most importantly, all parameters regarding the power with which the sonication technology is actually coming to your sample can be controlled by you. So if you're working with something that's releasing proteins that are likely to break apart very easily or degenerate, you're working with phosphoproteins, you don't need to hit it with the same power as you were if you were to talk about intracellular proteins. So at Covaris, what we have done is, and you will hear it also today, that essentially there are three stages that we talk about sample preparation. First is extraction from whichever matrix you're talking about. Today, you are going to hear primarily fresh frozen tissues or FFPE. So our FFPE something is, we take tremendous pride in saying that this is by far the only technology that can emulsify paraffin without use of any chemical, so to speak. So no need to use xylene or even mineral oil. It emulsifies, and which is why our ability to generate total nucleic acid from FFPE on the genomic side has been in existence for almost 10 years. And different forms and shapes, different throughput capabilities. So that's one aspect in terms of digestion and extraction. It is the whole process of pull down, purification is also heavily enabled by our AFA technology. Last but not the least, we see a tremendous benefit of accelerated or expedited digestion, which is typically what we do in the world of using PAC, protein aggregation capture, or sp3 beads being added to the sample and doing on-bead digestion, which usually shortens the whole overnight digestion down to 90 minutes. So I mentioned yesterday, I'm highlighting today, we have workflows. I mean, we talk about different matrices that we can potentially think of, or you can potentially think of. Today, for the interest of the audience here, we are going to focus on fresh frozen and FFPE. In particular, I mentioned yesterday we are launching a cell lysis. We have launched a cell lysis kit back in January, and we are also in the process of launching an FFPE kit for proteins, which will be out and about end of this month. So It's not necessarily a sneak preview, but those of you who had the ability and the interest to get up at 6 in the morning to come here at 7 and spend the hour with us, you definitely need to know that, what we are trying to do, what we are going to do pretty soon. So as such, what we are seeing, my apologies, the PowerPoint transition messed up the fonts. So all of a sudden I'm back in the typewriter domain. So essentially what we do over here is non-toxic deparaffinization, which is not necessarily not only not using the xylene or the mineral oil versions, but it's also very fast, followed by tissue homogenization, decross-linking. Everything's happening in the same tube or in the same plate. So essentially, we are trying to also minimize the total sample loss that you might incur otherwise. We are going to share some pretty good data. We also have a couple of posters, so you can see, depending on whether you have high wax or low wax amount, the blue is, of course, Covaris. We always see more proteins being generated, more peptides being generated compared to scrolls that you are obtaining or deparaffinizing using other methods. I can talk more about it at the poster session today if you have the time. In a nutshell, the workflow, it's not necessarily the circle of life, but it's the circle of FFPE. So we have got it. This can potentially also get automated depending on your throughput requirements. But you start with 110 micron scroll of an FFPE, and you get to roughly 100 plus micrograms of protein, 20 to 30 micrograms of peptides following the protocol, regardless of the tissue type. So like I said, I don't want to necessarily take too much of your time and time away from Mo and Lynn. Because I'm also waiting with bated breath to listen to them. So once again, we have these whole sample preparation workflows that we can talk about. Feel free to come by our booth. Feel free to catch us after this, if you want to discuss a little further.